Good morning. I would like to thank you for the invitation to participate in the BIM Coordinators Summit as a speaker. My name is Nicoleta Panagiotidou, and today I will talk about the strategic role of the international standard ISO 9650 in BIM implementation. First, I would like to introduce myself. I'm an architect with 15 years of experience in construction, and I'm currently researching a PhD in BIM at the UCL University in London. I'm also the founder of BIM Design Hub, an Autodesk training center specializing in integrating ISO BIM standards and Autodesk technology in the design and construction process. I also own the blog Break with an Architect, where I write articles about BIM and digital construction. I will start the presentation today with a quote from Benjamin Franklin that says the following: "The best way to teach someone something new is neither to tell it nor teach it, is to get people involved." This also applies to BIM and digital construction. According to the European BIM Task Group, the BIM process relates to four key areas: process, people, technology, and policy. The process area relates to methods and procedures and information management through international and national standards. The people sector is about leadership, collaboration, owner involvement, and the development of skills. The area of technology refers to BIM models, simulation, and interoperability. Finally, the policy area includes the integration and development of local guidelines and standards, contracts, and the legal aspect of the BIM process. Here we can see the countries with mandatory use of BIM in public works in red and countries with expected mandatory use of BIM in blue. We can see that the Northern European countries, such as the UK, the Netherlands, and the Nordic countries, are leading the way in BIM adoption through mandatory use of BIM in the public sector. There are also other cases, such as Poland and Lithuania, where the use of BIM is emerging gradually. Korea, China, and Japan are promoting BIM adoption through roadmaps and pilot projects. Several studies highlight the importance of the role of the public sector in BIM adoption, which plays various roles such as the regulator, the educator, and researcher. Since 2011, the UK government and the British Standard Institution have been developing standards and guidelines to support the adoption and implementation of BIM. Today, the government program called Digital Build Britain works on the strategic plan for the implementation of BIM Level 3. The UK BIM framework, created by the UK BIM Alliance, British Standard Institution, and the Centre of Digital BIM Britain, sets out the approach to implementing BIM in the UK, using the framework for information management based on the international standard ISO 9650, with a series of guidance documents. Globally, there are various organizations that develop and support BIM adoption, such as the Building Smart International, the EU BIM Task Group, the Cannes BIM, the Hong Kong BIM Institute, and others. Now let's discuss the BIM adoption drivers. The first driver is considered the international standard ISO 9650, which creates a common ground for implementing BIM in different construction markets. Second, project owners and governments recognize the benefits of BIM in terms of cost and time savings, leading to the mandatory use of BIM in many countries worldwide. Third, construction projects and teams are increasingly geographically dispersed, highlighting the need to adopt digital processes and establish a common language for digital collaboration. Here we can see some of the BIM guides which have been issued by various countries, organizations, institutions, and universities internationally. BIM is used all over the world, but is not equally defined in terms of standards and implementation. An international standard helps the industry agree on a common definition and a single process to increase the efficiency and quality of the implementation process. ISO 9650 is currently implemented in many markets such as Australia, China, and USA, while in Europe the interest in adopting the standard is constantly growing. Also, do you know that the word ISO comes from the Greek word isos, that means equal? In the diagram, we see the different standards in the construction industry. At the base, there are the professional codes, guidelines, and best practices. Next are the company technical specifications. Following are the private standards and consortia, and then the sponsor standards published by the British Standard Institution BSI, which are called publicly available specifications and are used as a basis for the development of the ISO standards. Following are the national standards, for example, the British standards, and the regional standards, for example, the European standards. Finally, at the top, there are the international standards, ISO. Here we can see the timeline of standards for the implementation of BIM in the UK from 2007 to 2021. BIM started in the UK in 2011 when the government set a strategic goal of mandatory implementation of BIM in all public works by 2016, known as BIM Level 2. The initial BIM Level 2 standards were used as a basis for the development of the ISO 9650 series. The first two ISO standards were published in 2018. Here we can see the ISO 9650 series and the UK BIM standards that are associated with them. The ISO series consists of 5 documents. ISO Part 1 and 2 refer to digitization and organization of data about civil engineer works and buildings, including BIM. The ISO 9650 Part 1 has the title Concepts and Principles, and Part 2 is about the delivery phase of the assets. ISO Part 3 focuses on managing the operational phase of the assets, and Part 5 describes a security-minded approach to information management. In ISO, there is also a provision for a national annex that includes relative national standards related to specific regions or countries. In the figure, we can see that ISO 9650 is implemented in the life cycle of the asset. The blue line indicates 3 points in the project delivery phase. A is the beginning, B is the development of the digital construction model, and C is the delivery phase, where the operational phase begins. We can see also that the ISO 9650 series is linked to ISO 50000, ISO 21500, the standards for project and asset management, and ISO 9001 that is about organizational management. Here we see ISO 9650 Part 1. The document describes the concepts and principles of information management. ISO Part 1 removes barriers to the collaborative process, enhances cross-border tendering, and reduces risk and cost through the use of asset model. The document describes a framework for collaboration, the introduction to the common data environment, the functions of information management for the project parties, and the information requirements. ISO Part 2 defines the management of information. This document helps the owner define the information requirements and determines the right commercial and collaborative environment for information production. The document also describes in detail the activities and tasks of the project parties at each project stage, from the assessment and need to the project closeout. The figure here shows the BIM maturity levels according to ISO. It follows the initial BIM Level 2 diagram, but also defines 4 development layers: the standards, the technology, the information, and the business layers. The implementation of BIM according to ISO is equivalent to Stage 2. The BIM Stage 2 requirements are the common data environment, structured and unstructured information, the use of information models, and the implementation of standards ISO 9650 Part 1 and 2. A successful outcome of the adoption of BIM processes according to the ISO 9650 will have the following characteristics: the clear definition of the information required by the project client or asset owner for the procedures and deadlines for the production and review of information. The quantity and quality of information are sufficient to meet the information requirements. Efficient transfer of information between parties. Informed and timely decision making. This diagram derives from ISO and describes the information requirements of a project. Information requirements include the questions that need to be answered to make key project-related decisions at different points during the delivery and operation of an asset. First, the owner states what he or she wants to be included in the information requirements. Then, the lead appointed party prepares a response for each requirement about how and when the team will deliver the requirements. The delivery team then delivers and manages the response to each requirement. Finally, the information is managed and approved by the client. In this process, there is feedback between the parties where necessary. Here we can see the information delivery cycle according to ISO. To have a better understanding of the cycle, we can consider these questions. What information do I know? What information is needed? Can my supply chain support it? Who delivers what and when? What are the information exchanges and how client decisions affect the process? What information do I need to manage the asset? In ISO, the life cycle is divided into 3 main stages and 8 activities. The first activity is the assessment and need. For example, if you wish to build a house, you should define the type of house, the materials, the area, when you want it to be delivered, and others. At this stage, the main active party is the appointed party, the client. Then is the procurement stage. The client will contact potential companies to undertake the project based on the project requirements. The client will then receive different quotes and proposals from the lead appointed parties and task teams. Following is the planning stage. After selecting the company, you will agree with them for the project's details, and then the company will mobilize the team and technology to design and construct the house. At this stage, all parties are involved. Next is the production stage. At this point, the lead appointed party and task teams will start to collaborate and design and construct the house. Before handing over the house, teams will conduct quality control and review the house. If the review is not successful in some aspects of the house, teams will need to start the collaborative production again. If the home is as requested and accepted by the client, then the last activity will be the project closeout. Based on ISO, each member of the project has specific functions for each stage. Here we can see the functions of the client, which include the definition of the project requirements, the creation of the protocol, the approval of information, the creation of the common data environment, and others. In blue, we see the functions of the lead appointed parties, those parties appointed by the client that include the response to the tender, the planning of the project, and the confirmation and management of information. With purple, we see the functions of the appointed parties, the parties that produce and coordinate the information for the project. In ISO, there are 4 types of information requirements: the organizational, the asset, the project, and the exchange information requirements. The types of requirements relate to each other and contribute to the creation of the asset and the project information model, the information deliverables. The principles of BIM according to the standard define that the disciplined models are created separately and then they are all combined together in the federated model, the composite model that combines all the information of the individual models. In the federated model, we can perform coordination and conflict controls, and we can work with other dimensions, such as time, cost, management, and energy analysis. The common data environment is also a requirement of ISO 9650. Here we see how the standard defines the collaborative process and the efficient exchange of information. The common data environment consists of 4 stages in which models are checked, approved, published, and stored, thus creating a reliable basis for collaboration during the project development. The diagram shows the level of information need that is a European standard published in 2020 and is also a requirement of ISO. The level of information need is defined by the geometrical and the alphanumerical information and the documentation. The new standard removes the LOD and LOI concepts, replacing them with the level of information need. This aligns with the goal of ISO to have one word, one standard for all BIM-related aspects. Another basic principle in BIM implementation in line with ISO 19650 is the Open BIM standards. For the successful collaboration between the different software, a series of standards have been created by Building Smart International, which facilitate the exchange of information. The best known standard is the Industry Foundation Classes, IFC, which is a file format that allows the exchange of data and geometry between different software, which has been included also in ISO standards. On the right, we see other forms of file that relate to the exchange of information in relation to procedures, technical specifications, and BIM objects. Here you can see the BIM courses offered by our center. The training is based on ISO 9650 Part 1 and 2 and is delivered through an educational platform with a rich learning environment. The training includes two courses, the BIM Foundations and the BIM Information Management. The first course presents the UK BIM standards, the transition to ISO 9650, and the key elements related to information management according to ISO. The second course includes a detailed understanding of the information delivery cycle in line with ISO Part 2 and describes the tasks of each party and the documents that support the BIM process. The courses are certified with the Continuous Professional Development System by the CBD Certification Service in the UK and has been on the shortlist of the European Excellence Awards 2021. Thank you for your attention. Please let me know if you have any questions.